everyone. I'm Jeff Hollan. I'm a program manager on the Azure Serverless team. I'm really excited to be here. Thank you. If you haven't seen enough of me yet, just you wait, all right? Okay, I am very excited to be here. I love coming out to these events. It is challenging, to be honest, because we have a full team of developers working very hard constantly back in Redmond. And so it is difficult to take time away to not be around to help answer questions or help them where they need. But it is so important to us as a team, which is why we all make an effort to come out. So I do love coming to these events. I really do. It's great to meet all of you, and again, to get feature requests and help you build all the features that we can then ship. So this is one where we're going to talk and do a bigger deep dive into Azure Functions, which I didn't even open in the last section. This is a shorter session. It's only half an hour, so I have a lot to cover. But Kevin mentioned this a bit before. I do think it's worth going into a little bit more detail on serverless. So if you have been paying attention, specifically across the industry, whether it's Microsoft, Amazon, Google, IBM, you name it, serverless is quickly becoming a very new buzzword. I hesitate to use that phrase, but it definitely is becoming a buzzword right along with DevOps and containers and microservices and all those other fun buzzwords that we get to say in all these presentations. But it is valuable to break down why we see serverless as being important, but more importantly, why we think it can add value to you and how you solve your problems. So Satya Nadella at Build during the keynote, he emphasized that he believes that serverless is the next generation of cloud computing, and that Microsoft is making significant investments into serverless. And when we talk about serverless in Azure, I first want to kind of set the stage. And this may be a repeat to some of you, but to some of you, it may be new and it's worth repeating. So if you look at the evolution of how apps are built and hosted, so you have a problem, you have something you need to solve, and you know that you need to build an application that needs to be available over the internet to solve it. So you have a number of different options, kind of spanning from high productivity to high control, that let you solve these problems. So on the far left, you have on-premises. If I need to create a program that resizes images whenever they're uploaded to a website, I could go to the local store, purchase a motherboard and a tower and a power supply, go home, build a computer, boot it up, install an operating system, get everything running, write my program on the operating system, make sure that it was running, and it would work, right? Expose the ports over the internet, and I've solved my problem. But there are a lot of questions and a lot of maintenance that I need to be aware of if I solve it that way, right? What if there's a power outage? What if I run out of hard drive space? What if I need to scale up? How many of these machines do I need to buy? What if I need to patch it, and so forth? So on-premises gives you high control, but you also have a high degree of maintenance and questions that you have to answer. So a few years ago, as you move up the stack, came along IaaS, or infrastructure as a service. And this is where cloud providers like Microsoft and Rackspace and Amazon said, you know what, instead of you having to go build or purchase your machines or maybe do co-location, we'll build and purchase and run data centers, and you can just spin up VMs whenever you need a machine. So you no longer have to worry about things like what if there's a power outage, or what if I need to get more of these. But you still have to worry about things like, well, what operating system should I use? And what if I need to upgrade my operating system? And what if I need to change out my application? How do I swap in versions of an application? So your number of questions that you're dealing with is drastically reduced, but there's still a high level of control. So finally then, or not finally, next we have platform as a service, or PaaS. And Dan did a good job of breaking this down in terms of the differences between PaaS and IaaS. And PaaS in the Azure world is like Azure App Services, where you no longer have to choose a VM or necessarily even an operating system. Now you just get your web code and you publish it to a platform like Azure App Services. And that platform takes care of patching. That platform takes care of availability and making sure that it's hosted and that the right ports are opened and that your certificates are there, which is great because now you can build websites much faster. But there's still a small bit of control that you do need. And if for Azure App Services, for example, I need to decide, do I need premium app services and pay a couple $100 a month? Or am I okay with basic or shared or standard? And even if I choose one of those tiers, do I need a size 1, size 2, size 3? So you need to be able to forecast your demand. And it's possible that you're paying for capacity or reserving capacity that you're not fully utilizing. So I think you know where this is headed. So this next evolution in cloud computing is serverless, where no longer are you control and have to worry about any of those questions. You simply provide your code or the work that needs to be done, publish it to the cloud, and resources are spun up on demand to execute your task. So that's really what serverless is. And the goal of this, the reason that you would be willing to give up all the control you had on premises, building your own hardware, to serverless, the goal of it is to help you build and deploy solutions faster. So where it is the right fit, where it works, serverless can add so much productivity to your workload. We were talking with a customer who's publishing a use case, and they had a massive project to do SAP integration, and they were leasing a bunch of SAP servers from this company, and that's a very expensive lease to have, leasing SAP servers. So they needed to move off of it very quickly. They chose serverless as the technology to enable them to do that, using Azure Functions and Logic Apps and the connectors there. And because they used serverless, they were able to move off of this leased SAP instances in just a month's time. Now that's an incredible rate of productivity. Could you have solved that by building your own data center or by using traditional IaaS solutions? Absolutely. But could you have solved it in that little of time? Potentially not. So that's what you're getting. That's the benefits of serverless. So in terms of what do we as Microsoft define as serverless, it really comes down to these three attributes. There's an abstraction of servers. Nowhere in the entire experience should you know that there's a server there running away. It's event-driven and instant scale. Because you're not reserving capacity, because you're not reserving resources, we need to be able to spin up those resources on demand, which means we need an event. We need some trigger. We need something to tell us you need compute for the next 30 seconds. So there has to be some event, whether it's a file is uploaded or an HTTP request is received or a message is dropped in a queue. Those are all events or timers or schedules, okay? And the last one is micro-billing. So you only pay for what you use, no more, no less. So what are the benefits? I kind of broke it down. Because you're not worried about those pieces of hardware and patching and scaling, it's very faster to develop, and it's it's much less work to maintain from the ops side. So you get a large reduction in DevOps. Wow, I'm really having a hard time speaking. This allows you to just focus on the business logic. If I want to write an application that whenever a photo is dropped into storage, it resizes that photo, I don't want to have to think of, well, what framework should I build this on? What operating system should it run on? I just want to give my 5 lines of code to resize an image and be done. And that's what serverless enables. Again, giving you faster time to market. So there are many offerings within Azure that fit those 3 categories and those 3 qualifiers. But when we look at the serverless offerings inside of Microsoft, it really resides around Azure Functions, which is serverless compute. That's where you upload, you can think of it like you traditionally write a console app, a little bit of C#. You take what would be a console app, you publish that to the cloud, that's an Azure function. That's all it is. You give it a couple dozen lines of code, attach it to an event, and that code will execute whenever that event occurs. So that's Azure Functions. That's the one I'll be going more into. And then there's obviously Logic Apps, which we've talked about already today. But it's surrounded by the platform in Azure, because there are many other pieces that enable the serverless platform, whether it's messaging with Service Bus, intelligence with cognitive services, data and storage. Those are all components of the platform that you'll use in serverless apps. And you obviously get very rich developer tools that I'll go into. So if you've seen the Azure Functions logo, this is the story behind it. So you have your code, and you have some event or data, and when those 2 things meet, you get Azure Functions. Wow, so exciting. Okay, so let me talk a little bit about what an Azure Function is made of. So I mentioned before, this is actually code to resize an image. This is all an Azure Function looks like when you open it up or when you deploy it. Very short, this is it. I didn't choose an OS, I didn't choose anything, I just wrote this code. But I do need to bind it to things. Potentially I need to bind it to an event so it knows when to run. And I might also want to bind outputs so that if I'm processing data, I can push that data somewhere. Because if I'm just processing data, it potentially isn't worth a whole lot. So where that comes in is you get what are called bindings. So in this example of this function app, I actually have 2 bindings. I have an input binding or a trigger binding, which is connected to a blob account. So I've given it the name image here, and you can see where I reference it in the code. And I also have an output binding, which is also to a blob account. In this case, they're just different containers within the same storage account. But you get the idea that here, I kind of have this relationship between my code, and I'm referencing these kind of variable names or these class names that reflect to my bindings. So there's a number of different bindings within Azure Functions. I'll show you a slide, my next slide, in fact, which goes into them. But just another kind of walking through this, you write your code, you can pass in bindings to things like storage to say when a file is uploaded, when a message is received, it executes your code on demand and goes back to sleep. So here's the bindings today, currently in Azure Functions. There's about a dozen of these between scheduling or HTTP endpoints, queues, topics, tables, push notifications, and so forth. In terms of the Logic Apps world, we will invoke any of your functions that have the HTTP trigger. We will be able to invoke them via HTTP within the data center or without the data center. It actually doesn't have to be there either. So let me go through building an Azure function now so you can see what it looks like. So I've gone ahead here, similar to where I went to new before, and I chose enterprise integration. The second greatest category is compute. And if you open up compute, you will notice we have things like VMs traditionally, and down here there's an Azure function. And so you can create a function app to run within your subscription. You give it a name, which will be part of the endpoint here. Choose your resource group. It is worth calling out, there are two hosting plans for Azure Functions, a consumption plan and an app service plan. Consumption plan is pure serverless. It will execute and scale up automatically on demand. If you already do have an app service plan, so you have some reserved compute for something like a website, and maybe you have excess capacity, you're only utilizing like 80% of your server farm, you can associate your function to deploy inside of an app service plan. And what that means is that your function won't be billed the serverless pricing, you'll only use the app service compute, which means that potentially you could be running it absolutely for free, but it does mean you need to make sure you have some excess compute in that app service plan. You associate it with a storage account so that it can store your code and anything else. And what's great here is you can actually turn on application insights to automatically emit all of your code directly to the portal. So I went ahead and created a function app already. So I'm not going to create one now in the interest of time. So this is, once the function's deployed, this is the function UI inside of the Azure portal. So after it would be built, this is what you would see. I don't have time to go into all of these pieces now, but I have kind of my function. I guess it's worth noting there are two pieces of a function. You have your function app, which in this case, my function app is called Integrate 2017 Law for Logic Apps. And inside of my function app, I could have many functions. So an individual function lives in a function app. And you can have multiple functions within a single app, doesn't really matter, but it's worth noting that there is that distinction. You can have something called proxies right here. I won't go into it right now, but in short, this is a way to put like a custom URL endpoint in front of any of your functions to call some custom backend URL. And you can also get slots to have different deployment slots for your functions. So you could have like a dev slot with dev functions and your prod slot, and then swap them, and then swap them, and then swap them. This is in preview right now, and you cannot use slots within the portal. You can only use slots if you're deploying within like Visual Studio Tools or Source Control. So once I have my function app, I can go ahead and create a function by clicking this little plus sign, which will let me create a function. And there are a bunch of languages that are supported here. So whether you want to write your function in C# or F# or JavaScript or TypeScript or PowerShell, all of those languages are supported. And so I can just easily create a function here, give it a name, say create, and now I have my function app ready to go. So I can test it right here within the portal. It's taking a little bit of time right now. I don't know if I'm in a different data center or something, who knows. So here's my code. I can write this right here. If I write it within the portal, I don't really get cool things like IntelliSense, so I have to be really good at writing code in Notepad. This is a good way to do dev interviews, is make them write their code in the functions portal. But I can also test. I can test my function right here. I can get the URL. I have some logs here. So that's kind of a basic overview. Again, how easy it is to just create a function. You define your stuff. I will comment there's this integrate tab, where you can specify your bindings. So maybe I want to output to a blob or to a queue. This is where I can configure those bindings right here within the portal. So within just a few seconds, you can write a function to process some data very, very quickly. Whether that function is to calculate the days between two things, which is what this function is, the one that I was running earlier. You'll see this is all it does. It takes the start date and the end date, and then it gives me the total days. It took me 15 seconds, and now I have this code that anytime I invoke this function, it will calculate those dates. Now, I have about 10 minutes left, so I do want to go through some of the other tooling that's available, because the portal tooling is extremely convenient, but one of the unique offerings that Azure provides with Functions is that you do get a local CLI and a local runtime where you can build and deploy all of these on your own machine. So if you're using Visual Studio 2017, and right now I believe it's only available in the preview, which anybody can download, and you can even have multiple versions installed, you can install the Azure Functions tools for Visual Studio. So you come in here to Tools, and you install the extension within Visual Studio, and there's this nice Azure Functions tools for Visual Studio 2017. The current version only does work in 2017, and it only does work in the preview right now, but you can use the free version. You don't have to pay any licenses. So I can go ahead here and create a new project. There's an Azure Function project, and this will create my function app. So what's great here is now, whereas before in the portal, I was writing in Notepad, here I have all of the power and familiarity of writing a class library within Visual Studio. So I can come in here and I can add different function apps. I can write unit tests on top of those function apps. I can run and test them all locally. I'll just go ahead and add a new function inside of my function app. We'll just leave the default name here. I can choose those different templates. So this one's going to be another HTTP trigger function. So again, now I'm within Visual Studio though. So I have great things like IntelliSense. So here I get create response. This is so convenient, okay? So that's great. But just like any other Visual Studio project, I could do something here like set a breakpoint, wherever you set breakpoints. Apparently I can't set a breakpoint right now for whatever reason. Oh, yeah, wow. I only play a dev on TV, apparently, okay? All right. Can we cut that out of the recording, please? Because if anyone back in Redmond sees that, I will never hear the end of it. It's jet lag. All right. So you can set a breakpoint. Thank you, kind audience. That was a test. And I can run this locally. So I do have the Azure Functions runtime. So you notice I'm not going to go ahead and test this for the sake of time, but I got an endpoint on localhost where I can test and invoke this function. I could even have this being invoked off of a queue that's in the cloud, and I can test it locally and have it trigger off of Service Bus in Azure, and that's totally fine. So it gives you great flexibility in testing these functions locally. The only other piece that I'll give you advice on, again for the sake of time, because I want to make sure that Derek, I guess we have a break after this, so I might go a little bit over. So that's the Visual Studio tooling. There is also a cross-platform CLI that you can use for your functions. So if you have Node.js installed, you can install a package called Azure Functions Core Tools. Is this clear enough to see? I'll make it a little bit bigger. Unless it's a pain to make it a little bit bigger, and then I might not. I can. It won't. It will just take a second. So I can install the npm file for Azure Functions Core Tools. Let's crank this up to 35. All right. Yeah, whatever. npm ig Azure Functions Core Tools, and that will install the runtime. Did it not? Whatever. And that will install the core runtime on my machine. So what's great here is now I get a new command line tool called Func. And you have to be very careful when you use this command line giving a presentation. So this is the Func command. And this lets you build, deploy, and manage your Azure functions directly within the CLI. So what's great, if you're developing a C# function, use the Visual Studio tools. It is absolutely the best for C# development. The breakpoints, the debugging, the deployment, everything is just very seamless. but using and building JavaScript applications in Visual Studio isn't necessarily as seamless. And that's where you might want to use something like Visual Studio Code, which is phenomenal at doing stuff like that. So I'm actually going to create a directory here called My Function App. And I'm going to show you how easy it is to build a function app locally for something like Visual Studio. So I have my func command, and you'll notice I have a bunch of commands here, like I can say func Azure to manage my Azure functions or deploy them in Azure. I also have these commands called func new and func init, which will allow me to create functions through the CLI. So I'll go ahead here and say func init to initialize this directory to have Azure functions. And you notice it created 3 files for us. And now I can say func new. And I hope you can see this okay. I apologize that my font was not as big. But what's great here is now within the CLI, I can choose something like the language. So I want a JavaScript function. I can choose the trigger, just like I was within Visual Studio. And that creates, I'll give it a name, my trigger.js. And that creates all the files that I need to run and debug this locally. So if I go ahead here and open up Visual Studio Code in this directory, if you haven't used Visual Studio Code, definitely check it out. It's an incredible offering. We just went to a serverless conference in Austin, Texas, and every company that was there, Google, Amazon, Microsoft, obviously, all use Visual Studio Code for their JavaScript development. So check it out. But you'll notice here, now I have my function app that I've created locally with the CLI. This is a JavaScript function. And Visual Studio Code has great support for adding breakpoints within JavaScript too. So I can come in here and say func run, and I can even expose a debugger. And what that's going to do is it's going to run my Azure function, similar to how I did in Visual Studio. This time I'm doing it through the CLI. It's going to ask me for firewall permissions because I just reinstalled this, which is fine. But I can come back in here to Visual Studio Code and attach my debugger and debug this now within Visual Studio Code. Again, all of this was possible through the client library. This is extremely effective if you want to do local development and local testing across any number of the different languages supported by Azure Functions. Once I've tested and written this function app and I feel good about the little bits of code and the bindings, I can go ahead and use that function tool to publish it to Azure. I won't do it right now because it's going to make me log in and I don't want to spend the time to log in. But if I said func Azure function app publish, and then I would give it the name of my function app. So like integrate 2017 LA, I believe that was the one. That would go ahead and publish my function app. Oh, maybe I actually am logged in. It's going to go ahead and publish this function app that I just wrote locally into the cloud so it can start executing there. So I know I went through a lot there. My intent was to give you a nice overview. There is one more piece I do want to go into. So you've seen Visual Studio tooling, you've seen Visual Studio Code tooling with the CLI. Those are a little bit less known. I haven't yet gone into, but I do want to show you the integration with application insights, because this is really powerful. And like I said, if you remembered when I created this function, it was as easy, oh no, my function fell asleep. Let me kick it back in. It was as easy as turning on that on toggle when I ran my function app. So let me wait for this. What I've done here is I wrote a function app, which might have gone asleep, which is okay because it was costing us a lot of money, where I'm dropping a file into a queue. I pick up the file, and for every file I pick up, I drop 2 more files into the same queue. And then I pick those 2 files, and I drop 2 more files. So it doesn't take very long for this thing to scale massively, and for there to be hundreds of thousands of these functions processing and tolling up my bill, so that when Jim sees my Azure expense for this month, he's going to be like, I thought serverless was cheap, and I'm going to say math. Okay? All right. So I'm here, and I'm going to go ahead and trigger that. But what's great here is that with application insights automatically enabled, I've done nothing to my code. Oh, it looks like it was running, and now I've just dropped in a new set of queues. Oops. I'll have to turn that off. Okay, but what's great here is I can see across my entire instance. All I did was define the code to pick up the queue and spawn it, split it in 2 like an evil snake. But I can see exactly how much compute is used. What's powerful here is you'll notice I actually have 190 different instances that are processing all these queue messages that have spanned out automatically for me. I did nothing to span out across 190 servers, which will probably be 300 servers pretty soon because I just started it again. But what's great here is with application insights, I can see exactly what's happening, how all of these are being processed and spanned out. With application insights, I also get additional control, so I can do things like application insights analytics. Again, I just want to emphasize while I'm showing this briefly, I didn't do anything to this function app to emit any custom telemetry. I just toggled that on button, and all of this just works out of the box. So for every request that is made, there is an entry given inside of Azure Application Insights. And so I can use the Azure Application Insights query language to query my data. So you'll notice here I said, just give me 5 results. Man, maybe I can't zoom in so much. Just give me the last 5 results of data. And you'll notice here I have logs. Every time one of these function apps is being triggered, it's creating a request log in Application Insights. I don't know how many of these I have. I probably have a bunch. Now, this Application Insights query language is extremely powerful. This is actually the same technology that we use internally at Microsoft to manage all of our telemetry for logic apps and our different services, so that we can very instantly see what our usage is, if there's any errors or exceptions. So I have here the different functions that have been running, and within a few lines of code, or not even that, with one line, I can say, let's summarize this data, and I want to summarize the average, no, I don't. I want to get the percentiles for the duration. I want to know how long each one of these function apps are running, and I want to know it by percentile. So I want to know in the 50th percentile, and the 75th percentile, and the 90th percentile, and the 99th percentile, how long a function takes to execute in my massive sprawl. So I click execute, and before I even finish the sentence, it's already analyzed all my data from all of those servers, and I know that for the average, the 50th percentile, it takes half a second, and in the 99th percentile, it can take up to 9 seconds to process. This gives me huge visibility into exactly how my serverless app is performing, so I can make changes, make it more efficient, maybe deploy it to different regions, whatever I have to do. It's also important to note that serverless, you do need to be a little bit okay with some latency. If you have to have the 50th percentile 100% of the time, you probably aren't going to get it. You might need to architect your app in a way that you're okay with 2 or 3 seconds. Obviously, I'm getting a lot of latency in some of these because I'm spanning so big. But again, that's just I'll just do one more query just to show you the power that you get from this App Insights Analytics. Let's get the average duration, but I actually want to bin it by timestamp of every hour. Now, what that's doing is it's going to get the average duration in hour slots. So from 1 p.m. to 2 p.m., what's the average duration? From 2 to 3, what's the average duration? So then I can do something like render a time chart. And again, I'm just trying to illustrate how quick it is that within a second or two, I now see across the entire day for each hour, what is my average duration? And it's even calling out and letting me know, like, oh, hey, by the way, 3 hours ago, your duration went massive, and I can click in here and try to analyze and figure out what changed. So that's kind of it for me on Azure Functions. Hopefully that was a good overview of some of the functionality across building your function app, debugging it, monitoring it. I didn't go so much into deployment, but I will just say you deploy function apps the same way you deploy web apps and app services. I'll just make a quick passing note because I am 3 minutes over. There is the Azure Functions runtime. This is just worth noting. This was announced at Build. And what the Azure Functions runtime does is just like I installed the runtime on my laptop to debug and to run my functions, I can use the Azure Functions runtime on IoT devices. The quote that Satya has is that data has gravity. So if I have a bunch of IoT devices emitting millions of events, I may not want to process and send all million events to the public Azure cloud so that they get processed there. I'm paying for ingress and egress, and it might just be more than I want to push. So Azure Functions Runtime actually lets you install the Functions Runtime on that device. So that device itself could run the same functions that we wrote and deployed in the cloud, process the data locally, and then potentially only pass the data up to the cloud or trigger something like a logic app if there's something worth doing that for. So this is new. It's in preview now. You can deploy it and manage it and play with it. It's the same runtime as the local debugger. Azure Functions is open source, so you can build and deploy any of this you want on your own machine and in Azure. So with that, if you have any questions on Azure Functions, feel free to find me. Hopefully that's been insightful. Similar to logic apps, if you haven't built a function before, just give it a shot. The cool thing with serverless is you can spend just an hour or two and you have some really cool stuff set up and ready to go. If you actually look on the Azure Functions documentation, they have a number of quick starts. One of them is using functions with logic apps. One of them is using functions with queue messages. Give it a shot, walk through it. It will take you step by step, and you can start to see some of the benefits that serverless computing can provide. So that's it. Thank you.